little bit of a demonstration on a PIV thing. So we're not going to exactly do PIV and do, but like a seeding, all that explanation, how to illuminate laser sheet, how you do pattern, you can take the images. So like last 2 days, if you see, we were using all high speed cameras, all that. In fact, some of the experiments, if you don't require high speed imaging system, all that, you can use simple SLR cameras. That is a small normal SLR camera. And illumination also, like yesterday PIV, we saw that what are all the things we need. We need some illumination source, then imaging thing, right? So here we have a camera, and since we are using a continuous laser, we don't require a timing unit. But if you use a pulse laser, you need to synchronize laser and the camera. And we have a small seeder there. So this seeder is, we are using olive oil seeder. So, and the air from the compressor, we have a tiny nozzle. So there is a tank. In the tank, there is a nozzle. So air goes into this so small tube. So maybe after that you can just, is it difficult to open? Okay. So this there will be a small tube going into the tank, and then air goes in and then comes like a bubbles out. So we have that seeder. So once we put the air, so then the small drops like a fog like thing will come and will be illuminated by these lasers. These are simple LED lasers, LED based ones. So where they cost about a couple of $100 or slightly around that thing. So yeah, let's start that. So you can see that the drops coming out, and then if you illuminate, you can clearly see the patterns. So you have these lasers. Just don't stand in that line. So these are generally used. Yeah. So this is the laser. So we are using two lasers here so that we get a bit more illumination. So again, if you have one laser and you're illuminating from side, so if you see that laser intensity will keep on decreasing, right? So so sometimes you will have that artifacts of one side you are getting more illumination. As it move through, the illumination keeps reducing. So that kind of a problem will be there. So either you use like a so high power one so that the illumination, still you can work out with the enough illumination, or use a multiple laser so that so you get some uniformity. Here we are using two of them. Then you can show, like I will start the seeding. So probably you can, maybe Vinod, you can reduce the seeding a bit. Yeah, over the edges you can see some patterns. At the middle you have all that like too dense seeding. So sides you have like you have a better seeding. This produces, the seeding produces the droplets of the order micron, right? So you can, now we try to take the images from the SLR. We can't no, oil drops in the flow, like say airflow. So this is the airflow coming out of the nozzle. So along, yeah, seeding is, here we are seeding the air, right? So because airflow we are passing through the like nozzle. So along with the air, some oil drops are coming. So this thing you can directly put into the any wind tunnel thing also. So then it will dilute further, and then you will have like seeding. So don't worry, this is olive oil. So olive oil seeding. So this is for air, we can use this, or yesterday I was telling like smoke. So these kind of things we can use. If it is for water, we can use particles like a polystyrene particles or glass spheres. So right, again it depends on the liquid. So eventually these whatever the particles you use, they have to be buoyant, and then if there is a flow, then they have to follow the flow. If you use a higher, let's say higher density liquids, then you can use higher density particles. So that's the thing. So you can just maybe Vignesh will show you the seeding things. Yeah, please, if you can explain about so open PIV little bit. So anyway, there are a lot of open source softwares available to do PIV. So you need not have any dedicated purchase anything. So all you need to is take images. Using these images, all these open source softwares like OpenPIV, PIV Lab, I think the newer versions, they are good enough. They have GUIs. No need to go to MATLAB coding also, right? So you can, yeah, Vignesh, can I explain about the process?
So first we extract images as we saw like yesterday. So we get the images first. So the images will be like that with seeding particles. Here, like first we see qualitatively. So we can see frame by frame. Like it is like qualitatively we can see the movement of vortex, which we can not see with the like from the naked eye. Only with the help of laser. Only at the like sheet where it is passing, we can see this information like vortices and others. What we want to get information qualitatively, then we need to go for a post processing, as Sir demonstrated yesterday, like cross correlation and other things. So this image, we will have it for now. We will go with some sample images which is already in there in PAV lab. So PAV lab is add-on available for MATLAB. It is available. So in same way, like OpenPAV is also there in Python. It is OpenPAV. In MATLAB, it is PAV lab. PAV lab is available as add-on for MATLAB. So if we go, you can see apps. In this, you can see you can like install app. You can go like you can install PAV lab. So it is already installed here. So maybe I can just close the previous session. I'll just go back, open PAV lab. You can see once you install, you can see PAV lab app here. So I will just open the PAV lab app. So it has come. So like we have options for importing images as well as videos. What you need is images in pairs. Like you have information from one frame to another frame, like how the like let us put it this way, how the seating particle is moved from like one point to another point, like that information we need. Otherwise, we can, if you have a video, from the video, you can extract the images, set by set images, we can extract. First, we will go for some sample image, whatever it is available there. First, we will go for a sample image. We will do analysis, some basic like process that we will demonstrate here. There are like, you can just play with it and you can get like even more like whatever you want to extract based on the problem, you have to do some pre-processing and other thing. What we are going to show is just some basic analysis, what you can do. So I can import some sample images. So we can say a simple case like Karman formation. So I just add it. So I import it to the PAV lab. Here you can see seeding particles are there. So you have some object in there. So here there is a flow.
Flow over a cylinder.
Yeah, flow over a cylinder. So if you want to see, like here you have to like one set of image, like between two frame, one set of image we have. So if you want to see, like let us say toggle, like between each frame, you can see like how the seeding particle is moving. The movement of seeding particle is nothing but the movement of the airflow or whatever the liquid. If it is liquid, medium, it is a liquid, or if it is airflow, it is air. The moving particle of the air is given by the movement of the seeding particle. So how we can get the movement of the seeding particle? So what I am going to do is just, it is like one click. If I want to do, I can do it. So I put analyze. Yeah, you get the velocity vector. So what is happening in the background? So it takes window size, windows, like each window, like it does cross correlation. This window size can be given by the user. So this window size, depending upon the window size, you get the velocity vectors. Now we will go back, change the window size, and we will see what happens. So okay, here you can see the movement is from left to right. Because of the cylinder over here, it is some like we are unable to see the complete vortex, but we can see a little bit of circulation is here. So now coming back, what happens if we change the window size? Okay, so I will go to the other options later. So first I will check the effect of window size. So I will take a single pass direct cross correlation. With this, it does cross correlation for only one time. So this is a like what is demonstrated, like in the, it is like a basic kind of thing. We take only like single pass of window, like cross correlation we do. So we take interrogation area of around 32 pixels. So step means like here you can see the window now. This window is here. So I have a window, like let us say 32 plus 32. So I have to, like in the next frame, like I have to take another window. This window should be somewhere closer to this. It should not be the like in the same location. It should be like somehow close. What I do is like I keep around 16 pixels from the first point. I move it to 16 pixel. I take it from the 16 pixel. I will just like move it and see where this cross correlation is happening. So let me do it. So you can see some spurious vectors up there. So let me go for, so this each at each window of 32 cross 32 pixel over here, we have a velocity vector. So if I say some 64, so generally 50% of like interrogation area is recommended. So you can see with at every 64 pixel, you got a velocity vector here. And some, we have still some spurious vectors here. Okay. So what happens if we do a double pass? Like let us say multi-pass we are doing. So pass one, it will take a like bigger window for cross correlation. Pass two, it will take again a smaller window. Whatever there in the pass two, we will get the velocity vector. So let me go with like default command, whatever it is there, I will just go with it. So you are seeing it. Okay. Some spurious vectors are not there, but we are able to see some like opposite vectors, which is like spurious vectors. On
there is a cylinder over there. So instead, you can mask that area.
Yeah. Also. So there is an, as Sir said, there is an option for masking also. So if you want to do masking, you can go here. You have to make masking like basic or free, and let us put a circle here. Okay. So here this information is not there. You have information around only. So it is one like if you have some cylinders are here, you can just mask it. Otherwise, you can choose a particular region of interest also, which you have here. So you can see different region of interest. You want to view only the particular region of interest, you can do that also. So these are the basics. Apart from that, if you have images very like low intensity is there, if you want to do some pre-processing. So what we can do is, so yeah, there are different kinds of pre-processing, image processing available. So we will go with some basic, whatever is there, we will just show you. One is adaptive histogram equalization. So it is called CLHA, contrast limited adaptive histogram equalization. So we have like it, like Windows says, we need to give the background is like it equalize, like it will, like in this contrast limited adaptive histogram equalization. Adaptive means you will not the overall image. You can choose a particular window site. Within this particular window site, you can equalize intensity value. You can correct. So
it is useful when you have non-uniform illumination. Sometimes just I was telling that when you pass the laser sheet, the one side it gets like more illumination, it keeps reducing. So you can equalize. Now we can see that it is
so this is a raw image. So if you want to see if you do some adaptive histogram equalization, you can see the intensity values like more clearly. So this is one thing. Apart from that, what if you have if you want to see only, let us cancel this. So we want to choose some particular frequency alone. Like we have intensity values where it is going to some particular frequency. You need that particular frequency only. So at that time, what you can do is you can give a filter. Let us say some high pass filter you want to give. So you see only the which has higher frequency, this intensity alone you are seeing. So if I use this filter, after that I go and analyze the frame. So it is like playing with different pre-processing techniques. You are going to play with it. So what you want to delete this, like spurious vectors are there. If you want to delete it, so it requires again you need to trial and error. You need to check. So if you want to check it, so validation, velocity based validation. You can, if you know the velocity limits, whatever the velocity. In this case, u velocity should not go negative or something. So what I choose is this velocity only. So sorry, it is going the negative, it should not go in the positive. So some vectors are, so some spurious vectors are gone. So like that, you have to choose case by case basis, trial and error. You can cancel the velocity vectors. So this is a basic process. So yesterday I said to you this are based on pixels. Like 1 pixel. So far I have shown is 1 pixel is equal to 1 mm. So what if you want to give calibration? If you know the calibration and time dt, as we saw earlier, distance between the 2 points and also the calibration. So you can go for calibration. So here you can give reference length. What is the reference length? What is the distance? What is the time step? You can give. So it is very simple. Once you have the image, you can process. So this is just basic what is in the foreground. I said you. Background is nothing but your cross correlation, which you have already seen. Okay. You can try different set of images. This will be always there. Like you have different set of images. Initially you can play with it. Like different cases here. It is once you install, you will see different cases. So this is a short introduction.
The seed diameter, seed particle diameter.
Seed particle diameter, we can also. This is for just like cross correlation only.
Previous.
From yes, you will just go back. So it is from right to this velocity vector. So if you see the velocity vector, it is from right to left. And the movement is from right to left. Yes.
If you put some tube-like structure.
So there is a cylinder here. It is passing over the cylinder.
Okay.
So because of the cylinder here, it is there is a circulation. Okay.